Here. Hello, my name is Nick Graham, and this is my graduate project for Introduction to Computer Science with Python. For this project, I chose to build what I'm calling a robo-trainer, which is a computer program that is capable of producing workout programs that balance both repetition and variety. And I chose to call it Aptum strength. Aptum is a Latin word that means adaptable or capable of adjusting to demands. So this is the agenda for the presentation today. I'm going to go over the problem that I'm trying to solve with this project, and then I'll go over my approach, including some of the basic design choices that I had to make in terms of how to approach the problem. Then I'll go into some of the Python libraries that I used and how I use those to address the problem. And then I'll present some of the results that I was able to generate with this project. And then finally, I'll discuss some challenges and limitations, which I think also lean into the way forward in terms of what I could do to improve this moving forward. All right, so what is the problem being addressed? It actually starts from a concept that was introduced by the founder of CrossFit, Greg Glassman, back in 2007, when he described the CrossFit prescription for exercise as being constantly varied, high-intensity functional movement. So for this project, what I did is I chose to focus in particular on the constantly varied portion of it, because I think that's somewhat vaguely defined here. And the surface area of what could be considered constantly varied is actually quite large. It could mean that you're changing up the exercises that you're doing on a daily basis. It could mean that you change it up on a weekly or monthly basis. It could mean that you never perform the same workout twice. There's a lot of different things that could potentially mean. And so I tried to come with a more narrow framing of what that constantly varied could potentially look like to provide both consistency and variety in an algorithmic and programmatic manner. So here's how I decided to come up with a description for the problem. Building a workout training plan that balances strength and conditioning, progressive overload and variety, and adapts to input over time is more art than science. But with modern technology, it's possible to automate much of the process in a rigorous way and improve training outcomes. So that's kind of the general framing that I chose to take to approach this problem. So now I'll get into my approach and some of the design choices that I made in building this program. So the first is I decided to come up with an overall workout plan structure that would consist of two parts. So a workout on any given day will consist of a strength component, so exercises designed to build strength, and then a conditioning component, exercises or a series of exercises designed to build conditioning. So an example of a strength exercise might be bench press, designed to build upper body strength. And conditioning could be something as simple as running 2 miles, something designed to build cardiovascular strength. And so I had to balance the concept of consistency and variety, for both of these components of the workout, but the challenges were different. So for the strength portion, what I chose to do is assemble a structured weekly rhythm for hitting as many strength movements as possible over the course of a week, and then maintain that structure across the entire duration of the program. I'll get into a little bit later some of the inputs that users can give that will shape the structure of the program, but one of them is the number of weeks that they want that program to be, as well as the number of days per week. So then coming up with how do I come up with a structure to vary the reps and sets? That was a different problem as well, and I'll address that here shortly. Then for conditioning variety, I chose, that could be just randomly selecting a conditioning workout from a list of pre-built conditioning workouts. And I decided to implement a little bit of control by allowing essentially a list of lists, so nested lists of workout. So in other words, you could have a list of running workouts, a list of biking workouts, a list of kind of muscular endurance workouts that involve push-ups and squats and pull-ups and things of that nature. And what you could do potentially in the way I chose to approach it is you could oversample a particular list within this overall list and use that as a way to, say, bias the conditioning towards running, if that's what you wanted to have a focus on. But still at the same time, it would allow for the sprinkling in of other types of workouts. So these are some of the basic design choices I made in terms of program structure. And then I also had to come up with a library of exercise movements and come up with an ontology for how to classify these. So I chose to do it by kind of three broad categories. The first is type. The second is what I call dynamic. And then the third I call demands. And so type is just, what type of movement is involved: a squat, a hinge, a lunge, a horizontal push. That would be something like a bench press, vertical push like an overhead press, horizontal pull. That would be like a dumbbell row, or a vertical pull, something like a pull-up or a rope climb. Then, movement dynamic. So something, a movement focused on strength, muscular endurance, an explosive movement, a stationary movement, like a plank, something like that. And then looking at the demands of that movement across kind of three axes, you could say. The first is central nervous system load. So that is how much load or demand is it that exercise place on the central nervous system. Something like, a squat places a very high load on the central nervous system. Something like a push-up, on the other hand, does not. The mobility demands of the exercise, something like a bench press doesn't really have robust mobility demands. Something, like an Olympic movement like a snatch does have very high mobility demands. And then skill, something like running doesn't really require a ton of skill. Something like doing a gymnastics movement like a muscle up does require skill. So I built out a library where I categorized a number of movements across all three of these domains. And something that was also a little bit interesting and challenging is that there are also some emergent properties based on the summation of some of these, the way that these exercises, when stacked together, and how that impacts a training program. So for example, if you're doing squats one day, deadlifts another day, these are things that have high CNS load. If you're doing that day after day after day, it can become additive, as opposed to if you kind of space those out, or have weeks that are high demand and weeks that are lower demand. So that was another challenge that I had to tackle as part of this project. All right, so now we'll get into reps and sets. And a big question that I had with this was how random. I could have gone with uniform randomness, using something like the random library's rand-in function, where the sets could be anywhere from 1 to 5, reps anywhere 1 to 50. But I felt like that could produce kind of some strange results that really wouldn't be useful. You could end up with 5 sets of 50 snatches, which is just way too much and not really useful for that training modality. Likewise, you could also end up with, say, 3 sets of 2 push-ups, something that's not really challenging and also not useful. So instead, what I chose to do is apply a sort of normal randomness, which allowed me to set a center or kind of a base case for both the sets and the reps, as well as a standard deviation, which is how much and should there be variation from that base case. So if the base case was 3 sets of 10 reps, if I set the standard deviation to 0, that would be the prescription across every single week. If instead I increase the standard deviation to 0.5 or 1 or 1.5, then you're going to get a lot of variety in terms of the sets and reps. So that's the approach that I chose to use. Now getting into some of the Python libraries that I use for this project. So I used NumPy, use that for the function you just saw in terms of being able to generate a normal distribution, which I used for calculating sets and reps. I use the pandas library quite extensively in this. I use that as a way to kind of structure the workouts into a table where you have certain exercises Monday, Tuesday, Wednesday, Friday, Saturday, or whatever the case might be. I use the requests library. That was because I actually dealt with APIs. I'll get into that in a little bit. JSON also related to, with the API request, I would get a JSON back. So I needed this library to handle that data. I used the random library. This allowed me to create the variation in terms of exercises that I chose from day to day. And then I also used the Pi Airtable library, which is a library for handling the Airtable APIs. So as I'll show a bit later in the presentation, I built out some workouts, workout tables in Airtable. It's just an easy database to work with. And then I would actually import that data into Python using the Airtable API and structure the workouts that way. Date time, to set dates for the workout. And then I also I did some work in Google Drive. Ultimately, what I wanted to do is export the workout in a easy to use format, and I chose Google Sheets as the program to export into. So I had to use a number of libraries that allowed me to work with Google Sheets and work with Google Drive to be able to perform that function. All right, so here's some of the results, and I'm going to start off by going over the inputs that I had. So I mentioned I had to basically come up with an ontology of exercises. So I did that in an Airtable database. You can see that here. A number of exercises for squat, for hinge, lunge, and so on and so forth. And I had to build this database entirely manually. Then you can see I also had this option to include or not. And as part of my code, if this box was unchecked, then this exercise would not be included in the workouts that were generated. So it's a easy manual way to kind of narrow the types of exercises that would be included in your workout plan. Then I also used Airtable as a database for storing conditioning workouts. And I was actually able to use Beautiful Soup to do some web scraping and create libraries like this. So you can see these are workouts known as the CrossFit benchmark workouts. And so I have an Airtable table of these workouts that I was able to create by using Beautiful Soup and scrape them from the website and then upload them into Airtable using the Pi Airtable API. So this was very useful because it actually allowed me to then take that code, that Beautiful Soup code, and go and scrape additional workouts from additional websites with only minor variations. So I was able to put together a relatively robust list of conditioning workouts, close to 300 of them, in very, very limited time once I had written that original piece of code. All right, so now I'll get into some of the results that I was able to generate with this project. So I allowed to have user inputs, number of weeks, number of days per week, weekly CNS load range, so they could specify kind of how demanding the total CNS load was across a given week. And then I also added this feature, the probability of what's called a hero workout, where they can specify the odds that a hero workout comes up as one of their conditioning workouts. So you can see here on the right, this table here, these are what are called CrossFit hero workouts. They're considered to be very, very demanding, very difficult. And so you could set this probability to 0. If you wanted to completely exclude these from your workout plan, you could leave it at 1%, 5%, 10%, whatever you would like. And then I also decided to add a kind of feature where if a hero workout showed up as the conditioning workout, then I would automatically eliminate the strength portion of that day's workout, just because the hero workouts are very demanding, very time consuming. So you can see in this given plan down here on Monday of week 3, a hero workout showed up. And so the strength portion is eliminated. So what happens is this program will take a couple of user inputs. Right now, they just have to be manually typed into the Python code. So number of weeks of training, days per week, CNS load, probability of a hero workout, and an email address. And then I run the code and it will automatically generate a workout to those specifications and share it out to the user's email address. So this is a sample workout that was generated. You can see 5 days a week for 3 weeks. and shared to my email address. And then similarly, this is just another example. This is 4 days a week for 4 weeks, another workout plan generated using slightly modified inputs here. So now lastly, I'll get into the challenges and limitations of this project. The first had to deal with user equipment available. This is something I wanted to address, but just didn't have the chance to get to it because of time constraints. And also the volume of conditioning workouts I was able to assemble, being over 300 of those, having to go through manually and say, what are the pieces of equipment you need to do this? But I think that's something that would be very valuable, in particular for travel, people who wanted to work out at home where they only have a few pieces of equipment, being able to specify, what equipment you have and then build a workout plan around just that workout equipment would be very useful. Second thing I think would also be useful that I didn't get to or didn't have a good way to tackle would be workout time. There's large variability in the time it takes to complete a bunch of these different workouts. But the practical reality is that most people are very time constrained in the time that they have to go and perform a workout. So, being able to go through and classify every workout and estimate approximately how much time it takes. I don't have a good approach to do that other than to do it manually. And that's something that I didn't get to in this project. Then, kind of the third piece that I think is very just difficult is determining how, quote, difficult a workout is. And I chose to use 3 concepts to approximate difficulty: CNS load, skill demand, mobility demand. But these are still relatively subjective. I don't know how accurately they really capture how difficult a given workout is. I don't know if there's a more objective standard that could be applied, but this is something that I don't feel I addressed terribly well in terms of this program so far. And that concludes the presentation. Thank you for watching.